coordinates, that is when you're dealing with slope specifically, you want to be able to identify whether a slope is positive, negative, or zero just based on the appearance of the particular function, right? So let's take a look at number 9. It says an xy coordinate plane above the slopes of lines A, B, and C are x, y, and z respectively. So let's get that information on the figure because it might be difficult to remember later on. So we know the slope of A is x. We know the slope of B is y. Let's write that here. And the slope of C is z. And this question is simply asking what is the relationship of x, y, and z. Now, this one's interesting because we have a coordinate plane, right? We have markings on the coordinate plane, so we can identify points and start to estimate the values of the slopes, right? But we actually don't need to do that in this particular question. Why? Because a slope that goes up is always going to be positive. A line that goes up, the slope of a line that goes down is going to be negative, and the slope of a line that goes horizontal is going to be 0, right? Between 0 and negative and positive. So if you know those things, you actually solve this question relatively quickly, right? Why? Because there's only one line that goes up, and that is C, right? And the line C represented the slope of Z, right? So it's going to be the positive one. So you know that's going to be the biggest, right? So we know that Z is going to be the biggest, right? Next up, we know that between 0 and negative, 0 is going to be in between, so we identify 0, that's y, that's going to be the second biggest. And lastly, we know that x is going down, it's going to be negative. No matter what it actually is, it's going to be smaller than 0 or a positive number, and therefore we have a relationship, right? And that's it. So number 8, not a problem. You just have to be able to estimate slopes based on their appearance. And again, if it's going up, it's positive. If it's going down, it's negative. Now, if it goes up more, that is, if it becomes steeper, then the actual value of the slope becomes relevant because the numerical value of it gets bigger, that is farther from 0. And same thing with negative slopes. If it gets more and more steep, pointing down, the number itself gets bigger. You know, the value gets smaller because you go from -2 to -10. That's smaller, but it's farther from 0. So just remember that like that. Okay, so not too bad. You just got to be able to estimate. And then we take a look at number 17. Okay, this one presents a line with a positive slope, and it has a square sort of lying right on it. It says an xy coordinate plane above, points A and D lie on line N as shown. If A, B, C, D is a square, what is the product of the slopes of line segments A, B, and C, D, right? Okay, so again, they're just asking for the product of the slopes. They're not asking for the actual slopes, right? So let's take a look. It says we need to find the slopes of A, B, and C, D, right? So A, B, and C, D. Yikes, right? Well, doesn't look like there's enough information on this particular graph to get, really sort of rigid points for them to find the slopes directly. So we're going to find the slopes indirectly. And that's where this little piece of information comes in handy, right? It says perpendicular lines have negative reciprocal slopes, right? Which means that if you find one slope and you know that the slope of the next line is perpendicular to it, then you can find this new slope by taking the negative reciprocal. So in this particular case, we can find the slope of this line M, right, and which AD is on, right? Why? Because it intersects the y-axis here and it intersects the x-axis here, right? So we know that we have 2 points here, right? So one point we have is 0, -1. And then we have 1, 2, 3, 4, 0. And we can find the slope here. I'm not going to do the slope formula just because you guys should know it. The slope is positive 1/4. Good. So that tells us that the slope of this line is positive 1/4. And we need to find the slopes of A, B, and C, D. Now, because this is a square, these are perpendicular, right? This form of right angles is a square, which means that the slope of both of these lines is going to be the negative reciprocal of M. So we can write that as the slope of the perpendicular is -4, right? So the slope of this line is -4. The slope of this line, or in the worst place possible, the slope of this line is -4. And they want to know the product of the slopes. -4 times -4 is 16. Okay, so sometimes you won't be able to find slopes directly, but you can use the fact that perpendicular slopes have negative reciprocal values.